Okay, page 204, 1 through 24. Markers are starting to die on me. So, you guys should all, if you have a calculator, it could probably do the first problems by itself. But I'm going to go ahead and go through this as if you don't have a calculator. You guys remember how we simplify square roots with the trees? What multiplies into 54?
9.
Okay, you do the factor tree. This is called prime factorization. And any doubles that you have are going to come out of the square root as a single. So in other words, since we have a double 3 here, there's going to be a normal 3 on the outside, and anything that's not double is going to be left over inside. So the inside is still going to have 3 times 2, 6. Okay, you might plug this square root of 54 in your calculator and see if you get this on your calculator. If you don't have a calculator, I've got a green box back there as calculators. It did. I did it first, so that's good to know. Makes me feel warm and fuzzy. Okay. On this one, square root of 6 does not simplify, but you're not supposed to leave a square root or any radical in the denominator. You guys know what radical means? Cue, corny joke, but the juniors aren't here. Radical means this symbol right here. Okay, so if there's any of those on the denominator, you're supposed to get rid of it. How do I get rid of square root of 6 in the denominator? Or the square root?
You times it by square root of 1.
Yeah, you multiply it by itself. And what happens is, what's square root of 6 times square root of 6? Whoops.
6.
It's square root of 36, which is normal 6. So anytime you square a square root, it just becomes a normal number. And what's the top? What's 1 times square root of 6? Square root of 6. So it's square root of 6 over 6. That's nice. Okay, number 5. Oh, fancy. Okay, I probably should know this, but I don't think we did this in Algebra 1. Did we? No. Okay, what number times itself equals negative 4?
None of them.
Nothing. 2 times 2 is 4, right? And what's negative 2 times negative 2? 4. This is called, anytime you have a square root of a negative, it's called an imaginary number. As if it doesn't exist. It doesn't exist. But evidently this has some kind of applications in like electronics or something, electrical engineering. I don't know. That's what I've been told. But anyway, what we're going to do is basically we're going to split this up. You don't have to write this every time, but if there's a negative, you can split it up into like square root of negative 4 is like square root of negative 1 times square root of 4. Okay, the square root of negative 1, this is the weird thing. Nothing times itself equals a negative. So what we do is we turn this thing into an I. And then we do square root of 4 like normal. What's the square root of 4? 2. So we call this 2I. Okay? Basically the negative and under the square root comes out and it turns into an I. The way we define I, it just equals the square root of negative 1. Okay, but basically how it works is if you have a negative in the square root, we turn it into an I. 2I, yeah, never mind. I'm kind of getting into tomorrow's assignment. We'll talk about that more tomorrow. Alright, anyways, that's it. So square root of 4 is 2. Square root of negative 4 is 2I. The end. Alright, number 7. I do think some of your calculators can do this. I think it might have to be in the right mode or something. Don't ask me to fix it for you because it'll take too long. Maybe I'll try it later. Number 7 is negative square root of negative 25. Did anybody try plugging in the calculator the last one? No? Okay.
Error.
Yeah,
It says error. Some, you can do it on most calculators, I'm pretty sure, but, has to be in the right setup. Alright, what's square root of negative 25 gonna be, you think?
It's gonna be -2. It's gonna be
Okay,
negative.
forget this negative for a second, just,
-1.
okay,
It'll be 5i.
right, square root of 25 is 5, so this will be 5i. The negative is still out there though, so altogether this is negative 5i. We didn't do that in Algebra 1, did we? I is new to you guys, right?
Yeah.
Okay. So number 9, square root of negative 20. I'm going to do the 20 just like a normal thing. 20 is 4 times 5. So 20 is going to be 2 square root of 5. But there's an I in it. So where we put the I is right there. Just, they had to put it someplace. They don't like putting numbers after the square root because it looks like it might be under the square root. So they usually put the numbers in front of the square root. And the letters and the whatever. So anyway, that would be the answer. If you plug in, even if you got an error, if you plugged in the square root of negative 20, if you plug in square root of 20, it will give you 2 square root of 5, and then you just have to put the I in yourself. Does that make sense? So you can just plug in square root of 20 in your calculator would give you 2 square root of 5, and you just need to know that you need to put an I in there. Number 11. 48, 45, this one's a big mess. Okay, so right off this bat, I know there's going to be an I in my answer. This has 2 problems. One of the problems is square root of 48 simplifies. The other problem is square root of 5 should not be in the denominator. All of this is under the square root. This would be the same thing as this. I could write it that way. Anyway, everything's in the square root. So how does square root of 48 simplify? 48 is 16 and 3. So it's going to be 4 square root of 3. Or 4i square root of 3. And then the square root of 5 is not supposed to stay on the bottom. Again, if you want to use your calculator, just plug it in without the negative. Some calculators can do the negative. And it would do everything except put the I in there for you. Just put an I. What do I do about the square root of 5? Multiply top and bottom by square root of 5. Square root of 3 times square root of 5, you can multiply those together, is square root of 15. On the bottom, what's square root of 5 times square root of 5?
Nothing.
It's just 5. Square root of 25, which is 5. Anytime you take a square root times itself, anytime you square a square root, it just eliminates the radical. Okay, does this reduce or anything? No. A square root and a normal number, you can't multiply them, you can't divide them, they don't mix. If the 4 and 5 reduced, right here, if 4 and 5 reduces, then we should reduce that, but it doesn't, so that's the final answer. So if you plugged in your calculator without the negative, you should have got 4 squared root of 15 over 5, and you just put the I in there. Actually, your calculator might write it this way. Well, actually, if your calculator did work, sometimes they put the I out there outside of the fraction like that. That's whatever, it's all good. I think the book puts it in the fraction. No, I lied. They put it outside the fraction. Number 13. Okay, yesterday we were solving equations like this, And how did we do it yesterday?
We got everything on one side with the zero, like X.
Yeah, we got everything to one side like it is right now. We factored it, and then we said, what's the opposite that would make this 0? So today we have some problems that are a little more like this. Okay, this doesn't factor, but we can get, if there's just an x squared and not an x term, we can just get x squared by itself. It's a little simpler today. So if I subtract the 9, this is not this problem, is it? No. If I subtract the 9 over, I get that. If x squared is negative 9, how would I solve that for x? Okay, let me back up. If x squared equals 9, what could x be in this case? 3 or negative 3. Because negative 3 times negative 3 is also 9, right? So what we do, how do I get rid of a square? What's the opposite of a square? Square root. So basically we square root both sides. But when you use that trick, you have to remember it could be positive or negative 3. Those both work on these problems, if you ever use the square root trick. So if I square root this, I'm going to get x equals, those cancel out, plus or minus 3i. Okay, this is not number 13, this is just a bunch of junk I made up to help us with this section, so you might need to erase that if you put it on 13. Alright, 13 says x squared equals 169. So how do I solve that for x? Square root. Does anybody know what square root of 169 is? 13. So it's x equals plus or minus 13. The square root of 196 is 14. So that's kind of confusing because they look similar. Easy peasy, right? 13. No. It took like 3 seconds. Negative 4y squared equals 20. Guess what I should do first on this one? And who's being sassy? Is that you? What should I do on this one? Divide by negative 4. Get the y squared by itself, then it's going to look like the last one. Y squared equals 20 divided by negative 4 is negative 5. Then what do I do? How do I get y by itself? Get rid of the square root? Or get rid of the square by using the square root?
It's number 21.
This is 21? No, whoops.
Yeah.
Yeah, you're correct. Alright, I'm going to finish it though. Almost done. Alright. What's the answer going to be? Does square root of 5 simplify? No. What do we do with the negative? Okay, I still did something wrong. Ding, ding, ding. Correct. Lots of little things to remember, right? So, all these equations that we're solving with the square root, you have to use plus or minus. If there's a negative in the radical, it comes out as an I. How about, we're not really doing this today, but how about like the cube root of negative 8? Is that imaginary? Is anything cubed equal negative 8? Negative 2. So cube roots do not have imaginary things. There's actually something that could work for this. Negative 2, because negative 2 cubed is negative 8. But square roots don't work. Actually, square roots, fourth roots, sixth roots, even roots can't have a negative. Alright, where am I at? I was supposed to be doing 15, which is z squared equals negative 27. Okay, so we're ready for the square root. Just going to do that. Z equals, does square root of 27 simplify? Yes, it does. To 3, square root of 3. What did I do wrong? What else did I do wrong? Okay, this one has a plus 4 on the left side. So what do I need to do? Subtract 4 to get a squared by itself. A squared equals negative 4. So if I take the square root, I get a equals plus or minus square root of 4 is 2, so it's 2i. Okay, 19. Alright. Says 24 minus 3z squared equals negative 24. Negative 24. Okay, this kind of looks like 19 from yesterday. Why yesterday did we move everything to the left side and factor it, but today we're just getting z squared by itself? The reason is basically this is simpler than yesterday. If it just has a z squared and not a z term, it's not a 3-term factoring. It's you just get a z squared by itself. Anyways, what do you guys think I should do first on this one? Minus 24. Negative 24 minus 4. 24 is negative 48. Divide by negative 3. 16. So z equals 4.
4 times 4 is 16.
So plus minus 4.
Oh.
And you could check your answers just like all equations. You could plug those both in and make sure they work. Some kinds of problems that we're going to be doing later, you have to check answers because sometimes you get extra answers that don't actually work. But that's not today. 21, we already did that. 23, 7x squared minus 22. Equals 4x squared plus 8. Kale, what do you think would be a good first step on this one? Yep, and how would I do that? Yeah, just like a normal get the x by itself thing. We subtract 4x squared. Does square root of 10 simplify? No. Only 5 times 2 goes into 10. And that does not, doesn't do it. There's no doubles in it. got about 23 minutes, or 18 minutes.